Okay, now this is the hard part. Going back the other direction, we're going to use a lot of weird formulas here. The first one, if we want to write things in terms of r theta, is we have to find the radius. The radius actually comes from the Pythagorean theorem, and that is that the radius squared equals the x value squared plus the y value squared. That's the Pythagorean theorem, where the radius is simply your hypotenuse. Now if we solve for r, we simply take the square root of both sides, and that equals this. Now remember, the radius is normally a positive, so we don't have to put a plus or minus in front of this radical. It's just r equals the square root of x squared plus y squared. Now, to find the theta part, that's even trickier. We're going to have to take the ratio of y and x and set that equal to the tangent of theta, and then do some inverse values. So it's a three-step process, as you can see here. Determine what quadrant you're in, find r, and then find tangent, and then finding theta using tangent, that is. Now we are assuming, and this is important to note, that the radius is greater than 0. That means that we're assuming that the radius is positive. Okay, so that's why, again, this formula here just is a positive square root. We're also assuming that theta is going to be between 0 and 2 pi, so somewhere in that first positive rotation around the axes. Okay, that's a good thing to know. All right, so number 11, how do I find the radius and the rotation if my regular x and y, rectangular means just x and y values, like we're normally used to graphing, what would that be in terms of polar coordinates, where we're talking about r and theta? Well, r would equal the square root of x squared plus y squared, which in this case is 1 squared plus the negative root 3 squared. Okay, 1 squared is 1. Negative root 3 squared. Okay, a negative times a negative is a positive. Root 3 times root 3 is root 9, which is just 3. So the square root of 1 plus 3, square root of 4, which is 2. So r equals 2. Then we also need to find the theta. So we use the formula that the tangent of theta equals y over x. Okay, so the tangent of theta equals y, which is negative root 3, over x, which is 1. Which is basically negative square root of 3. Now, if you look on the table on page 541, you'll see that in the first quadrant, the reference angle here is pi over 3. Now, are we actually in the first quadrant? No, because tangent is a negative number. So actually, let's go to that page 541. Let's see. Okay, I think it actually gives you an answer that is negative pi over 3. That's what it is. So they give you a fourth quadrant angle. But you know what? We already know that we're in the fourth quadrant, because in the fourth quadrant, x is positive and y is negative. So basically, we already know that theta has got to be somewhere here. Okay. But basically our answer has to be between 0 and 2 pi, so we're talking about the positive rotation, not the negative. So rather than calling this negative pi over 3, we're going to call it the positive version of that. And since we're exactly pi over 3 away from the x-axis, that would be also equal to 5 pi over 3. So that turns out to be our theta, is 5 pi over 3. This far away from the x-axis in the fourth quadrant. So our answer for our polar coordinate, now that we have r and we have theta, is 2, 5 pi over 3. Now I kind of did that one backwards because I was supposed to think about what quadrant I was in first. I kind of did it more towards the end, but that would be a good thing to think about first. So this one's a little trickier because the quadrant isn't quite clear. In fact, we're not actually in a quadrant. If I'm at 0, negative 4, again, this is an x and a y, I would be x, a value of 0, y value of 4, 1, 2, 3, 4. I'd be down here. I'm actually on the y-axis, down here between the third and fourth quadrants. So this one's pretty easy because if I rotated around and I stopped here, what's the radius? Well, duh, I'm exactly 4 units down from the origin. So it's pretty obvious to tell that the radius on this rotation stopping here would be 4. If you have to do the formula, again, we could do r equals square root of x squared plus y squared. But you can see that that even is pretty easy. 0 squared plus 4 squared will be the square root of 16, which is 4. Either way, the radius is 4. Now from the diagram, what rotational position are we at? Well, this is, again, pretty easy. This would be pi over 2, pi. This position down here, if you rotate all the way over to there, would be 3 pi over 2. So, well, there it is. That's theta. So my final answer for the polar coordinates of r and theta is 3 pi over 2.